Hello and welcome to the Stars of Physics. In this video, we shall see resistors in parallel. For this, we have to consider different n number of resistors. Now, time being, what we'll do is we will find out this formula for 3 resistors and then we will generalize it for n number of resistors. So, I will consider this first resistor. We will call this resistor as R1. Then we have second resistor. We will call this one as R2. And this one is the third resistor. We will call it as R3. Now we want to connect them in parallel, so they will be connected like this, parallel. Okay, so I will just connect this side as it is. Now different current will flow through all these 3 resistors. Therefore, we have to connect different ammeters to measure the current over here. Say I will connect this ammeter to measure I1 here, which will be the current through our first resistor, that is R1. Then I will connect second ammeter over here to measure current through R2, and the third ammeter will give us current I3, which will flow through R3. Then we will combine this together. Now the different currents will flow through these 3 resistors because they are connected in parallel. And then I will connect a battery and I will complete this circuit over here. This circuit is completed. Now to measure the voltage here, so what this current will flow through this circuit, say I amount of current will flow through here, the I amount of current will flow from here. Now there is a branching, therefore what will happen, this I current will be divided into 3 parts, I1, I2, I3, and that will, I1 will flow through R1, I2 will flow through R2, and I3 will flow through R3, and again it will be combined here, and the same amount of current I will flow after this. Okay, so this will be our I current, and these 3 are the I1, I2, I3. Now to measure the voltage drop across these resistors, now since they are connected in parallel, therefore the voltage drop will be same across all these 3 resistors. So I will connect a voltmeter. So this is the voltmeter I am connecting here. There will be same voltage drop across all these 3 resistors. Okay. Now, first of all, we have to consider what will be the current flowing through this parallel combination of these 3. So what will be the current flowing through the parallel combination of all these 3? So say I will call this parallel combination as RP, suppose the final result RP. And since I is the current flowing through this RP parallel combination, therefore, according to Ohm's law, we get V is equal to I multiplied by RP. So this is our equation number 1. V is equal to I multiplied by RP. This is equation number 1. Now for each individual resistors, we can write down Ohm's law. Now here for this resistor R1, we have this voltage V is equal to I1 multiplied by R1. Then for this second resistor R2, we have V is equal to I2 multiplied by R2. And for this third resistor, we have V is equal to I3 multiplied by R3. Now, from these equations, if I want to find out current, then from equation number 1, what will be the value of current? From equation number 1, the current I will be equal to capital V divided by RP. Then from this is the same as equation 1, so I will call it as equation 1 only. Then from this, this implies that our I1 will be equal to V divided by R1. Then this implies that I2 is equal to V divided by R2, and this implies that I3 is equal to V divided by R3. So this is our equation set 2A, this is 2B, and this is equation number 2C. Now, since this is the nodal point over here, so what will happen? The current coming over here will be same thing as current branching from this side. Therefore, at this particular point, we get the value of current is equal to capital I is equal to I1 plus I2 plus I3. Okay, so this will be the current. So I will call this as equation number 3. Now, if we substitute this equation number 1 and equations 2a, 2b and 2c in equation number 3, what we will get here? We will get V divided by Rp is equal to this capital V divided by R1, because I1 is V divided by R1. Then this is I2. I2 is V divided by R2, then plus V divided by R3. Now here, V is common over here in all these things, and therefore what will happen? We can cancel out capital V from this. So what we get here after cancelling this, I will cancel this rather. We'll just cancel this capital V from all these. So what we get here is 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Okay. Now this is nothing but the parallel combination resistor. When we want to find the parallel combination resistors here, so we will get this 1 upon R1, 1 plus 1 upon R2 plus 1 upon R3 as 1 upon Rp. So if you want to generalize this for n number of resistors, say I have this first resistor R1, then I have R2, then I have suppose Rn, that is n number of resistors I have. Then by using the same logic, we can generalize this relation for n number of resistors. So for that purpose, what it will be? It will be nothing but 1 upon Rp will be equal to 1 upon R1 plus 1 upon R2 plus so on, and plus it will be last term 1 upon Rn. So this will give the total parallel resistance for n number of resistors. I hope that you understand this. Do like, subscribe, share and comment. And if you have any difficulty, you can comment in so that I can answer those questions.